everyone. My name is Ashima Sharma and I'm pursuing my Masters in Computer Science and Application from Thapa University. We are here to discuss about my project titled Setting Up an Ethernet with VLAN and PTP on a Microcontroller Hardware Setup. So moving on towards my project, it includes various subsections as porting a TCP/IP stack on microcontroller hardware, further moving the stack on an LWIP stack, which is a part of a TCP/IP stack with VLAN. And the third and the foremost part is porting this LWIP stack with PTP. And then using all of these, we have to port this on a gigabit Ethernet hardware. Now, moving towards what my project is all about is, since I am working on an automotive domain, so why this Ethernet came into picture was, initially we had these ECUs in a car. Now what this main problem was, all these ECUs were arranged in a mesh topology, and the other thing was, during that time the ECUs were quite a less in number. With further advancement, what came into picture was, next slide please, that CAN and FlexRay came into existence. No doubt the topology, it changed to bus topology, but still CAN and FlexRay were not enough to provide a high-speed communication amongst these ECUs in the car. Then with advancement in time, what happened was, these approximate 5 to 6 ECUs, they increased to a number of almost 70 ECUs in a company which are manufacturing these cars. As you can see, all these ECUs came into existence with advancement in time. So when these ECUs increased to a drastic number, what was the major requirement was a greater bandwidth and a more reliable mode of communication. So when all these requirements were there into picture, Ethernet came into existence. As you can see, the hunger for bandwidth, it gradually increased from 1982 from 100 bits per second to almost 100 megabits per second when we were coming to 2014. Now for all of these things, the main essential part of the project is Ethernet, as we are going to communicate amongst all these ECUs with Ethernet. So this is the frame format for Ethernet. It includes a destination MAC, source of the MAC. There is this section, which is basically the VLAN section, which adds an add-on functionality to the Ethernet to provide more security and to reduce the traffic. Further, there is a Ethernet size, which defines the type of the frame, and also there is a payload, which is the data. And then there is a CRC, which is cyclic redundancy check, to check the error bits. Now, along with this Ethernet, we need to use a stack. Initially, we were using TCP/IP stack. Then we came up with this LWIP stack. LWIP stack is just that it includes majorly this network layer and the transport layer. And why it is an advantage over TCP/IP is because it contains considerably less number of APIs. Then also my project contains a major section which is termed as VLAN, virtual LAN. What it basically consists is, all these ECUs were initially clubbed together onto a single network. With advancement, when we thought of VLAN, what we are going to do is, we are going to separate these ECUs on separate different networks. These lines, they are indicating, these colors, different colors are indicating different VLANs, which will come into picture once we port VLAN on this LWIP stack. Another thing there is precision time protocol. How precision time protocol is helpful is, it is basically a master-slave clock protocol. There is a master and there is a slave, and they both communicate with the help of a clock. Next slide please. So this precisely describes how this PTP functions. This is the master, this is the slave. Master sends a synchronization message, and accordingly the slave will send a response, and this way they'll be able to communicate with each other, and both will function on the same clock. Now how I am testing my project is, I have a PC which is connected with a debugger license. Further, I have a target platform, which is basically the development kit. On this side, I have a test bench application, which includes all the test cases which I'm going to apply on my PC. And I have another PC which basically includes Wireshark, which will be detecting my frames which are being transferred on the network. So this is a screenshot from my project. This includes an ARP frame, request and reply. These two packets, they have been captured with the Wireshark when the packets were being sent from a PC to the network. So this is my status for the coming months. I'm done with my requirement phase, design phase. Half of the implementation phase has been done when it comes to VLAN. All the other remaining sections will be completed in the upcoming 6 months of my internship. Thank you.